Right, so recording, let's have a look then. So when it says find the value of y when x is 0, what did you do? So we've got y equals x squared minus 7x plus 10. So when x equals 0, basically replacing the x with zeros. So the y would be 0 squared minus 7 times 0 plus 10. And you get the answer y equals 10. Why is that, based on what we've been doing in the past, why is that significant with our step theory? It's actually, well, y equals 10, this number here is the y-axis intercept. That's why I asked you to add that. Okay. So that's an A. B, use your answer to plot where the graph crosses the y-axis. So if I'm doing this, I would say, if I make my grid a bit bigger. So actually it says, yeah, use your graph to plot. So we must draw this. I know that my graph crosses at 10. All right, so that's what it's saying. The y-axis crosses at 10. So that's one of the points. Now we've been doing it, that's the last point, in fact, but they did. So the next thing then says solve the equation x squared. So x squared minus 7x plus 10 equals 0. Now we've done that, potentially not spent a lot of time looking at what that form looks like. So when we solve for equaling 0, it basically means find the x-axis intercepts, because that's when y equals 0. So that's along this line, right? Remember we've been doing that? All right, so that's where y equals 0. So we're looking for the x-axis intercept. So how do we do that? What's the first thing we need to do? What form do we need to put it in? Factorized form. So let's do factorized form. I can always print this out afterwards. So let's do factorized form. Can you remember the factorized form? How do we get it? So we've only got 1x squared, so x and x. What multiplies to make 10? 5 times 2. This is negative, but this is positive, which means both must be negative. So I know it must be negative and negative. Do 5 and 2 add to make 7? Yeah. So this would be minus 5, minus another 2, makes minus 7. So negative 5 times negative 2 is? No. Positive 10. But what's negative 5 add negative 2? Negative 10. So Eden said 5 times 2 makes 10. It's positive, so positive 5, positive 2. But positive 5 and positive 2, you add them together, make positive 7. So how do I get negative 7? Well, I have to add together the two negatives. So we could have had 5 times 2 to make positive 10, but 5 plus 2 doesn't make negative 7. So the other way of making positive 10 is negative 5 times negative 2. And negative 5 plus negative 2 is negative 7. So that's the brackets, but do you remember what we have to do now? use the null factor law. What's the null factor law? If two things multiply to make 0, then each one must equal 0. So we've got x minus 5 has to equal 0, or x minus 2 has to equal 0. So what's the answer? What minus 5 makes 0? 5. So x equals 5, and on this one, x has to equal 2. All right. So there's my solutions. Solving that equals 0. So what does that mean? Well, let's have a look at that. Use your answers to help you plot where the graph crosses the x-axis. Well, that's what we've just done. So where does it cross? It crosses at 5 and 2. So let's put 2 there, and let's put 5. But they're negatives, but these ones, the solutions are not, right? X equals positive 5, x equals positive 2. Now, should we just check, by the way? So let's just check something. We've got y equals x squared minus 7x plus 10. What happens if we put x equals 5 into this? Well, we get y equals 5 squared minus 7 times 5 plus 10. So what's 5 squared? 25. Minus 7 times 5?
-10.
7 times 5. 7, 35. So minus 35 plus 10. And then what's 25 minus 35? Negative 10. We've still got to add 10. What's negative 10 add 10? So we've shown that that number does in fact give me the 0, right? So not the negative, the positive. So that's where it crosses. And then it says, sketch the graph. Now, we have done one extra thing, which is, what are we missing at the moment? Line of symmetry, also known as the axis of symmetry. What's the equation of that line? X equals, yeah. Yeah, well done. 5. Yeah. So I know the vertex is on that line. How do I figure out the y coordinate of the vertex? So it's going to be at 3.5 something. How do you find the something? That's the y value, isn't it? That's the x value, that's the y. How do I find it? Let's check back in your notes. Let's send this. Which equation are we going to use? This one or the original one, or which one would you prefer to use? The original one, okay. Y equals x squared minus 7x plus 10. We're going to use x as 3.5. You might need a calculator. So we've got 3.5 squared minus 7 times 3.5 plus 10. So can you do that? Can you do 3.5 squared? 12.25. minus, can you do 7 times 3.5? 24.5. Can you do 12.25, subtract 24.5, then add 10? On board, look, 12.25, subtract 24.5, then add 10. You do it? Anyone on? Sorry, I'm waiting. Do it again then. 12.25, subtract 24.5 plus 10.
Plus 10.
Plus 10.
Yeah, it still says error.
12.25, subtract 24.5 plus 10. Negative 2.25. That one, not that one, yeah? Did you use this one? 12.25. Show me what you did.
I probably must.
Do it again.
What?
So we've got y equals negative 2.25. That's the y coordinate. So we can replace the question mark now with the negative 2.25. So that's about, if I look at the scale that I've used, I'm just sketching, it's not, that's 10, look, 2, right? So I'm going to put negative 2.25 probably around here. Yeah, are you happy with that? So that's at 3.5 and it's at negative 2.25, just to show people that I know the numbers. And then we've got to do the sketch. So I know my line, and this is, I guess, the final important bit. It's when you've worked out these super important parts. So you've got this point here, you've got this point, and we've just worked out that point. When we sketch, all right, we could actually go across, look, 3.5, 3.5. I know it's going to go over there as well, don't I? At 10. Why do I know that? Good answer. That's not, yeah, that's exactly what I was hoping to get. It's a line of symmetry. Therefore, I know that these points are equal, this one's on it. If that's 10, I know there's another 10 the other side. And that's going to help me sketch, because I can go down, right, through that point, through this point, come to the bottom, nice curve, and then go up. Tell you what, that's not bad, is it? On Monday morning. Alright, it's not bad. Try not to do like a sharp, pointy thing at the bottom. It's a curve and it comes down and then goes back up. So it's got to go through, or at least as close as you can get to go through those points you've worked out. Alright. Now, if I did do that one and I just drove up and went like that, I mean, it's just going to look funny, isn't it? So by putting that other point in my sketch now looks quite nice. So I am recording, but let me just, when you sketch, it's quite important that your quadratic curve is generally kind of like that, yeah? What we've got to try and avoid is to have curves that do like this, where it comes back in, because that doesn't happen, right? It also doesn't go straight down and then go straight up. So we should be looking at the best possible way to have a curve, and at the bottom there, a curve. So if you something like that, we're good. Some people tend to do this, which doesn't, it's not very good either. And you tend to do that because if you've got that point, this point, and this point, it's very easy just to go, oh, it must be a triangle, but it's not a triangle. Right? We try and draw it down, and we would then go down and go further down than you think you need. So that's pretty much it. Because if you did it like this, for instance, if that was the axis like that, if that was the 2 and the 5, then you've got to make it go through the 10. haven't you? So if it goes straight up, it's not going to reach. Yeah, that's yeah. So that you're missing that 10. So how do you feel about that whole question? So we've gone a little bit further than they don't ask for the axis of symmetry, but I hope you know. How do you feel? Shall I can just print that page off? What?